Okay, guys, we come to the next static analysis or static testing, which is static analysis. So static analysis, from the name, it's analyzing the code. Now, just meeting and check the code with other people. That's mean, okay, we review. Someone will review your works. But here you can use some tools to analyze your code or your document. Mostly is talking about document here. I mean, in static analysis about code. But maybe can apply for if you write your specification in formal methods. Also can use some statistical analysis, not statistical, static analysis. Okay, guys, is it clear this work? When we talk about static analysis, we use some tools. We use some tools to analyze the code or analyze the document. So as we see, we are talking about code. But if you write another document in standard way using some formal specification, if you just maybe Google formal specification, you get many formal specification for writing, for example, the specification for designing the system. This is also can be analyzed using these tools. So in static analysis, from the name, as we see, is indicate that the code will not, okay, first, the code will be analyzed using tools or methods. So I will teach you, or I will show you that the methods that's used, but there is some tools also can be used or doing the same job. So similar to the static testing review, there is no execution for this code. Just use the tool or use the methods to analyze the code. Okay, as a normal memory, we can say the object also is find defects that tend to make or cause an error in the document. So we analyze some the problem, or we analyze the code to find some errors that make some fault. So here an example of static analysis. We have, for example, if we see spell checker in your, for example, this is also can be used for any document, not only the code. So this is one kind of analyzing or tool analysis. So we have also the compiler. So the compiler here is also one example of code analysis. So in the how it's work, how we can say based on the definition of this, which is analyze the code, how the compiler can be one example of this static analysis. Actually, if you know that the code or when you're writing your software or your program, you will find, or the compiler in that language, for example, C or Java or this, they will show you some errors. If you write, for example, the F in different than the standard format of F, or different standard, or different than, for example, or the while, or so when you write it, they will show you that it's errors. So that's why we see this is now tool, and it help you to detect that error. So this is the first one, will help you to detect that error, which is a normal. This is for example, check the syntax. Also, there is some special tools also can be used for programming or for this statistical analysis. So we will see some methods that can be used for analyzing the documents. So here, what we can detect. Okay, here actually, okay, the first one, as I mentioned, mostly it's use some tools. Okay, this analysis use some tools. So it's because sometimes it's difficult. For example, we have some methods, we will use it, and this is also as I told you, it can be done also by methods. So this type of static analysis is use some tools to detect the defects. So we analyze the code and then we see if there is any defects. So example of that, for example, the code analysis can focus on coding standards. coding standards. For example, if you you should when you're writing the code, what you should follow some standards. So this is here, for example, if we talk about the coding, for example, maybe okay, the name of variables, also the space before you're writing some sentence. So this is also, it can help you to some application or some software tools can help you. Also, if you have, there is some syntax error. Also, this is some codes also can help you, syntax error. So this is the compiler, this is the job of the compiler. Okay, this is another, this is if you talk about the tools and the syntax, also the standards of writing. So also there is another thing, so we can talk about it here in the static analysis. For example, the line of code, number of line of codes. So this is also based on that, you can check, okay, you can guess, oh, this code is complicated or not. So to calculate, for example, that's the first one can be, okay, the line of codes, how many lines. So based on that lines, you can say, oh, my code is complicated. The second thing also is it's called the code matrix, which is the first one is line, number of lines. The second one, cyclomatic number. Cyclomatic number, this is actually, it's methods to calculate the complexity of your code, the complexity of your codes. We have another also, which is the code structure. The code structures, this is two things to analyze the code structure. The first one is the control flow. The second one is the data flow. So using this type of, or these methods, you can analyze your code. You can analyze your code. So here, this method, as we say, if you, for example, the compilers to check, for example, if there is any deviation from the standards, so there is any errors, any syntax errors. So this one, can be detected using that analysis. The second one, which is the code matrix, we have some matrix that can be used also to analyze the code here in these two methods, which is the complexity. And then the third one is also can analyze the structure of the code, which is also two methods, which is the control flow and the data flow. We will go through these two, the second and the third one, because the first one is the compiler. I just bring on this next slide is just one example of the compiler. This is the compiler. If you see here, the compiler can help you if you miss something, for example, Z. If you see this line, Z equal to X plus nothing. So once you click, the compiler will see, okay, this is wrong here. There is something missing here. So this is also from under the analysis. So the compiler will help. So this is the first tool, for example, that's can help for analyze your code, which is the compiler. So as mentioned, we have now 3 parts, something like anything about if there's any deviation, okay, deviations from the standard. This can be detected by the code or by the compilers. Code matrix, we'll see these 2 types. Okay, we can say the second tab only because the first one is easy, just line, the number of lines. The second one is the cyclomatic numbers to calculate the complexity. We have also the code structures, which is the control flow and data flow. So here is the compiler. You see the compiler, how can detect the code. I think you are familiar with that. So okay, here, okay, this is maybe one slide. We have to talk about it. Which one is first? Now, when it's better to first to apply, for example, the static analysis, or first is review. They say here is the static analysis is being conducted first, because when you're writing, for example, when you write your code, the compiler will work. So you just first start with static analysis. And as we say, okay, this is because static analysis is conducted by the tools. So it's conducted by itself, no need to do it. So it's better to add or to do the static analysis before the review. So here, as we see, is why we start with the control flow. Okay, no problem. control and data flow, which is the structure analysis. So in control flow actually is just okay. The purpose first one, the purpose of control flow. So okay, guys, the control flow, it's the sequence. Is we can say is the presentation show the sequence of the code. This is the control flow. So based on that presentation or diagram or graph, you will see some defect or some bug, or as they call it here, anomalies. Okay, maybe if you see this word is previously is anomalies. I don't know where I see it. Okay, so they call it is anomalies, but it's okay, it's bug or defect, is no problem. So this is the first one, which is the control flow and data flow. Just is representation of your code, but different way. They represent, for example, the first one for the control flow using graph. So then based on that graph, you can see if you're, for example, if you're the clarity of your code, is it easy to trace or no? So this is for the control flow. So as I mentioned, this is the example of control flow. So as they define here is an abstract representation showing the sequence of the statement executing while the program is running. So if you see here, the first, for example, the node here, it's represent the statement. The node is represent the statement, while the edge here represent, okay, the between the statement, the translation or transport from one to another one. Okay. So the edge here is possible execution sequence of the statement represented by the node. Is okay. Because maybe sometimes we have more than one possible, so they wrote it here, possible execution. So we have two elements of this execution of this control flow. The first one is the node. So the node is represent the statement of the program, and the edge, it's the way between this statement. So the possible way between these statement. So here the edge is the possible way between. For example, we have statement 1, 2, 3. So we have 1, it can go to 2 or can go to 3. So here, once we have 2, that means we have here conditions, or we have if statement. Or we can have also if statement or case statement or half loop. So all of them, it's also can be represented by this edge. So guys, this is the first one. We still not talk about it. What's this is the control flow. The control flow is just graph represent the sequence of the execution of your program. So here also one thing to talk about it is can be determined by the control. So because if we don't have, for example, this edge, we don't know what's the flow of this application. So and this is determined by the statement like go to or condition or loop or case. So this is the edge. So what else here? Okay, we talk about it, this one. So here an example of control flow graph. Control flow graph, if we have this, for example, this code, we want to create the control flow. We just first, we have to number all these sentence. We have to number all these sentence. After that, we see the way or the flow from one sentence to another sentence. So here also some sentence actually it can be combined together. For example, here from 4 to 6, it can be you can use 1, 2, 3, for example, is no problem. I mean 4, 5, 6, or you can combine together. Here because they are in one, it's all can be say okay. I can say they will execute it once together, so we can combine them together. So here to create the control flow, we have first to number all these statement. After that, we create node and edge for this program. I don't think it's that difficult. It's so easy. So here one thing is to remember here when we write about I mean, each one should have, for example, now we have the start, we have the end. And then if we have any F, you will find the two parts should have two H. For F, we have two H. For example, here we have, they combine 2 and 3. But okay, for example, 3 is the H, the statement, F statement. So we have 2. Here we have while, the same is like we have 2 also statement. Okay, and this is represent the F. So how we can use it actually for analyze the code? How we can use this graph for analyzing the code? Okay, we have here some defects that can be detected by this graph. For example, we can easily notice. Okay, first, if, as I mentioned, if your graphs, it's hard to trace, is difficult, there is a lot of branch. So this one, that means this is your application, it's complicated. So better to rework. That's part of, this is the second point here. I mean, if now your graph is clear, so that means your code is clear. Your code is easy to maintenance. So the second one, if there is something is okay, some defect can be detected using that graph. For example, if there is jumping, for example, out of the loops, so it can be detected. And if some sentence not reachable, you have, for example, one sentence here. Okay, it's go, for example, you have, for example, here 4, and then you go to 4, but it's not used. So this is also, it can be detected by this graph. Program segment with several exits. Okay, if you have several exits, maybe it's also can cause some defect. So this is also some anomalies can be detected by this code or this graph. We have an example. Actually, we have also another techniques to show this. So guys, here actually, okay, as I say, completing the evaluation, how we can evaluate this or how we can take the benefit of this graph. Okay, we can create a table. We can create a table from the same from the same example. We create a table, and then if you see here, for example, if for example some of this sentence without precedence, so without, for example, because in each sentence, with the exception of the first one and the last one, each one should have the point before, which is preceders, and the second one, which is the successors. We have these two sentences. We have one is before and one is after. So if one of them, for example, as we say, with the exception of the first and the last sentence. So if one of them without preceders or one of them without successors, so means there is something error. So there is some unused sentence, So there is one method to also do what we can say, as I mentioned, to evaluate also the graph. If you see here, we have now the sentence from 1 to 13, same sentence. And then here, for example, the first one, which is the successors, which is the preceders. So we have to, for example, after fill up this table, if anyone occur without successors or without preceders, so that means there is something here. We cannot say it's not the defect, but at least there is some unnecessary computations. Okay, unnecessary computations. So we have to delete some unreachable, for example, sentence. So also this one can help you to detect some errors. Okay, so guys, we have also, maybe we have only a few slides now. Let me see the time. Okay, maybe it's better to finish because we still have time. So guys, we see here, we have also another methods to calculate the complexity of the system. complexity of any system, of any program. So we have here what we call it is cyclomatic number. Cyclomatic number. If this number is high, means your application or your system is more complicated. It's complicated. So we have to reduce some, for example, some loops, we reduce some if statements, so to make it's easier. So this one, it's used to calculate the complexity of the system. So based on the graphs, you see the graphs that you have. So we have the edge, so the number of edge, the number of nodes, and then plus 2. The edge minus the node plus 2. So this is how we calculate the complexity, how to calculate the complexity of, there is many different types of complexity, but here we select the cyclomatic complexity. So as we see here, we have the graph. Based on that graph, we just see how many edge we have, how many node we have, and then the number of edge minus number of nodes plus 2. So this is will give you the cyclomatic number of cyclomatic complexity. So here an example, if you see here, we have now 9 edge, right? Edge, yes, 9 edge, which is the line, then minus 10 edge minus 9 node plus 2. So here the complexity or the cyclomatic number is 3. Number of the complexity is 3. So the same things, okay, maybe this is the number. So what we can do for this number, as we see here, the evaluating of this, if the number is higher, based on some studies, if the number of higher than 10 means your application it's complicated. Your application is complicated. Guys, this is actually can be calculated. I mean, not only the number, because if you see the edge minus the nodes. So if, for example, maybe will be the same number for big application, also the same number, maybe it can be, for example, 3 for this application. Okay. If you have, for example, also big application, the number nodes is 100, and so maybe there will be also 3. So not means that's because if you see minus, it will cut the number. So as they mention here, if the number is higher than 10, that means your application it's complicated. So we have to rework the part of that's complicated. So if 6 or less than 6 is acceptable, okay, according to this, which is also, this is the metric. This is another metric. So this is the cyclomatic complexity. So, and how we can calculate the cyclomatic complexity. Okay, I think this is the last topic, guys. Which is data flow analysis. Data flow analysis, okay, similar to the flow analysis. There we focus on the flow of the application. Here the same thing, but we focus on the information itself, the variables of the application, the variables of the application. So we have to know where's the application start, and then what's the effect of the application in this in each statement. Okay, so just here in this, we will take one methods to analyze the data flow, which is use and define. Then based on that, you will see, okay, my application, okay, this variable is used or not used. This variable is used or not used. So if you see this application or this program is just for swap between two numbers. If you see here, we have A and B, and then we want to swap between them. So if this is just, okay, maybe if you see here, we just try to trace or follow up with these two numbers, where is go and then when it's end. But we have another methods to analyze the data flow. Here we have something we call it is define and use. And the purpose of this just to detect unused application, unused variables. So here we have, let's see the example, the example. So, okay, let's see this example. If you see here, we have this example. We have three variables, and then we key n, and then based on that n, we will go to loop. If the n is 0, we'll go out to this loop, and or we will go for this sum with n, and then increments, and then input. Again, if the input is not 0, they will go another loop. Once n is 0, they will get out from this loop. So here in application, or this is simple program. So we want to just see the flow of the data. Okay, as you see here, this is actually the table it can use for detect either if the application is used or not used, or sometimes it's is defined but is not used. So we have two words, which is, as I mentioned here, this method is called define and use. This method is called define and use testing. So it's the simple one. There is many other methods for data flow analysis, but we just this one to detect unused variables. So we have these three. This is the code now. This is the same code that we have, right? And then for each variable in this code, we separate one column. And then we see here, for example, we start with I. So I, it's used here, or define here, because it's the assignment sentence or statement. So it's define, and then here is define and use. Use because we have here +1. So it's use, define and use. And then here it's print is use. Okay, the previous slide, actually, we will go back to that slide, but it's better to understand now. So here, the second one, which is n, is define here because it's input, so it's defined, similar to these two, is defined also. So, and then it's use because it's comparison with 0, it's use, define, because it's input. So the same thing, it goes to other one, which is sum. So guys, from this table, for example, you can say if for example here we have define, and then it's nothing there, we cannot if for example there is no use after define, so we can say there is unused variable. So we can fix this problem. Sometimes we have define, and then our which can say is double define. So this is also is defect. If you, that's mean you have there is unnecessary sentence if there is to define. So this is type of defect that can be detected by these methods. Okay. So let's see now, based on what we say, we call this one define and use. So here actually, okay. Define, actually, if there is any assignment statement or input statement. So this is, we call it is define. If we have another tab, which is, for example, the node where the variable is used, for example, for computations, for example, for comparison, for output, for iteration. So this is also, it's called its use. So here we have define and use, and this is what type of use. If any iteration, it's used. Output, it's used. If you see here also, for example, this is output, it's also use. So this is how to determine that it's use or define. So as we see, this is the data flow, which is easy way. It's not that difficult. There is another way, for example, which is in and out. So this is in and out is another. It's more complicated than these methods. So in that method, we can just, okay, we have a set of variable, and in each statement, we have what is set, what is the input, and what is the output. Means what's the member of, or the elements of the statement, or the in statement, in set or out set. Another method, guys, is not these methods. So here is the data flow. data flow. So also can be detect some defects. Okay. Is there defined but never used? This is what we can detect. Something, if there is something is defined but never used. Something is used but never define use. For example, from the beginning you start use, or here is used, but there is no define. So also this is defect. If something is defined more than one times without using, for example. So this is the type of defect that can be detected by these methods.
I'm sorry, I have a question.
Yes,
Okay.
yes.
So what do you mean we use when you declare like int, in, and sum? So
when
it means that you're using it.
Okay.
So what is the point? We need to define it.
Based on what we decide this is used or defined, right? Is that your question?
Yeah, I mean where you have this code.
Okay.
How we can improve, like you just need to define it in the state of declaring, or what? What is
how we can, okay, if you talk how to improve it first, okay, how to say this is used or define. So based on this slide, you can say define. We have the define. It's if we have this assignment, for example, x equal to 1, so this is define, or input, this is define. So if we have another things like, okay, we have a predicate, we have computations, we have output, we have iteration, so this is we can say is used. Okay, this is the first point. So the second point, now after we define this table and we say we detect, okay, let's say here we create this table, and then there is some as we say something like here, for example, let's say for the first one, something there is defined without use. Define without use. You define one variable, for example, let's say there is no use here, there is no use here. So what's means you define an application or define a variable, but you don't use it. So what you have to do to improve that's good, either maybe there is a defect, by the way, maybe there is, you define this variable but you don't use it, maybe you forget to use it, or maybe there is, okay, these unnecessary variables and you have to delete it. So this is how we can maybe use these methods. Just as we said, there's something like these three sentences. If there is something defined but is not used, if something is defined multiplies or more than one, if something is used but never defined, okay, this is also can be detected by the compiler. If sometime, like, okay, just write the sum, it's okay, for example, sum equals sum plus n, but you don't have any value in sum. So this is also is defect. Maybe, okay, maybe you wanted the default is 0, but maybe there is some defect that you have to insert some value. You don't have to use it without value. And that's why we say, okay, the initial value can be also detected by on initial variables. How should be improved? I just say, okay, how we can improve. For example, let's say, okay, the input here we are talking about, let's say this sentence is not there, input, this sentence is not there. So, and then you come to check the flow of n. So we have here use, and we say there is no, this sentence number 4 is not exit. So we have use define. So what's means there is something wrong here. There is anomalies here. So we have to back and see what's the wrong here. We have to maybe check the requirement. We go, okay, do we need to import something or no? How we can, for example, write while based on n, and n is not defined yet. So this is how we can use this table, or not only the table, this technique, which is data flow. Is it clear?
Yes, somehow.
Okay, again. I say, okay, now it's, I think as I told you, we have different, there is maybe as we say, simple things that can be detected, which is something, okay, can be detected by the compiler. But okay, if sometime, okay, as we say, if we don't have, for example, this sentence, and then now when we try to follow up with, or try to follow the data or the data of n variables, you will find, okay, I'm trying here now to use now undefined variables. How is that? So we have to improve that code. How we improve it? I mean, how to, this is now detect. This is a defect. This is defect because you use something not defined. So we have to check what input should be, what we have to input. Is it any initial value, or we have to input some value? Because as we say, this one, we assume that this syntax is not there. This syntax is not there. So we use something not defined. So we have to find what's this, or what the value of this thing. So guys, now maybe we come to the last slide. The last slide. Yes, the last slide. The last one. The next one is the thank you for listening. So maybe guys, when we talk about the analysis. Okay, guys, the last slide here. Okay, we talk now about a different type of static analysis. As we say, they use some statistical analysis. If sometime you have code with 100 lines, it's okay, acceptable. You can count it and you can maybe check the flow and then check the data. But if more than this, so actually there is some tools. There is some tools and do the same job that you see here. Now, when you see the control flow, the same job can be done by another tools. So also, for example, if you see this, the first picture here, this tool actually can calculate the complexity, which is the one we just learned, is cyclomatic complexity. So this method, for example, another one here, it can be detect some fault. Also, this can be add, which is find bug. You can do it by hand, but if your application is big, maybe it's better also to use some applications. Here. I give some example here. I already use, this is okay. For example, the first one is the compiler, the find bug. I use it here. Is it maybe just if you want to use it, just to add it to the Eclipse, you can add it to the Eclipse. This one also, Sonar, so it also can be used for detect some bugs. What the idea behind that tool is the same what we learn. As we say, okay, for example, the complexity, they use the same methods, but they use tool to do that. Here, we use it is manually.